In Chapter 9, we talked about gases. In this chapter, we're going to talk specifically about liquids and solids. We'll start off with a little bit of an introduction, and then we'll talk about the intermolecular forces that actually define liquids and solids relative to gases, and then we'll start talking about some of the features of both solids and liquids. As we've discussed in the past, there are three phases of matter, and there could be a fourth because we could have added in here plasma, but most of the time we talk about these three different phases of matter. A gas, which has neither a definite volume or a definite shape, a liquid that has a definite volume but has no definite shape, and a solid, which has a definite volume and a definite shape. From kinetic theory, which we talked about in the gas chapter, matter consists of tiny particles in constant motion. And so we're going to still use that theory to actually define both liquids and solids. Let's discuss the three phases of matter and do it relative to kinetic molecular theory. Let's start off by talking about gases in review. Gases are particles that are in continuous rapid motion. That sounds like kinetic motion. Particles are widely spaced apart. These particles travel large distances before colliding, so kinetic motion again. And gases have no fixed volume or shape. That is illustrated here in the CO2 bubbles that are in a glass of soda. Those CO2 molecules, once they escape the liquid, they tend to be in rapid motion and they have no fixed space. Liquids, they're closely spaced particles. They do have a fixed volume, but they can randomly arrange, meaning they can move relative to one another. They also are in constant collision with their neighbors, which again sounds like kinetic motion theory. And they can move past each other, kinetic motion theory. That's illustrated here by the liquid in this glass of soda. Molecules moving relative to each other. And finally, solids. Solids are closely packed particles, often in very regular arrays, often known as crystals. They have fixed locations. However, they do vibrate back and forth. Oh, again, that sounds like kinetic motion. These are rigid materials, and often the external shape reflects the inner structure of the solid, meaning a crystal lattice. That is shown here in ice, which sort of looks like this very ordered type of structure which we call crystals, as illustrated by the ice in this glass of soda water. So why isn't everything a gas? There must be something holding these solids and these liquids together, whereas a gas is sort of free to move around. This force that holds liquids and solids together are called intermolecular forces. In other words, attractions between molecules. So in a gas, at least in an ideal gas, there are no attractions between molecules. If I look at a liquid, they have some more forces between molecules that actually attract them together. So as I go from a gas to a liquid, I have more intermolecular forces. If I go from a liquid to a solid, I have even more intermolecular forces. So if I look at the kinetic motion theory, these molecules, they're in motion by vibrations and rotations. These have vibrations and rotations, but they can also move relative to each other. They can sort of slide past each other. And if I go to a gas, they have a lot of energy and they can move randomly about without even interacting with each other. So we can sort of say that the transitions between solid, liquid, and gaseous states of a substance, they occur when conditions of temperature or pressure favor either the kinetic forces, meaning kinetic forces to break all those solids and liquids up, over the intermolecular forces, which tend to hold things together and make them a solid. And I can sort of transition between these three states by either changing the temperature or the pressure.